Hello everyone. We will solve this today LeetCode problem. This is a product of array except itself. This is an medium problem. This is an given an integer array nums. Return an array answer such that answer I is equals to the product of all elements of nums except nums I. So we need to find the product of all elements of nums except this nums. It means that if we need to find the nums product of at index I, so it will be equals to 3 to 6 plus 4 is equal into 24. For index 2 we will multiply all the elements except 2, that will be equals to 12. And now so we have given that we have to write algorithm that runs in O of n time, and we can't use division method, right? So what I can do is I can store a prefix array, and I can store a prefix array and a suffix array, and then I will whenever I move to for every index, like let's suppose, let's take an example of 1 2 3 and 4. Then for storing the prefix array, 1 2 prefix multiplication array, so it equals to 6 and this is equals to 24. And now I will also store the suffix, which will be equals to 4. Then it will be equals to 12, and now it becomes 24, and now it will becomes 24 again, right? So this will be the prefix and the suffix multiplication array for this particular example. So if suppose we find answer for this first index, so we need to see its previous prefix and its next suffix array value. So it is 0, so its next prefix will be previous prefix will be 0 1, let's suppose, and its next suffix array is 24, so this for this answer will be 24. Again for this 2, its previous is 1 and its next is 12, so for this the answer will be 12 into 1, which is equals to 12, right? For third, its previous is 2 and its next suffix is 4, which is equals to 2 into 4, which is equals to 8. Now again for the last index, we can't see its suffix, so we will see its previous, which is equals to 6, right? Because why we are seeing its previous and the next, because we don't need to include the particular element. Here is what is written except nums, right? So here is how we found the answer, but the space complexity will be O of n, and but the time complexity will be O of n, but the space complexity will be O of 2n, because we are using two arrays, extra arrays, right? Two extra arrays. So how we will optimize it further, right? So if you see, if you see that, then for a suffix array, or we can use only one array, and for another array we can simply replace it by a variable, right? Which variable? Any variable. Let's take a variable suffix, right, which initializes to 1. So this is prefix array we have stored in an array. Now from the last we can simply multiply this suffix value, and this can store the value that in our answer. What I try to say that, let's suppose this is suffix 1, so for last index this 24 is already present here for fourth index, so we will see its previous value 6, and we have not multiplied this nums value into suffix yet, so the answer will be for this will be this previous value, previous prefix minus 1 into now current current suffix, which is not equals to multiply by 4, right? Now we will multiply the suffix by the num size value. This is an answer for that particular index, right? We have already stored prefix multiplication in a particular array, so we have reduced from 2 extra arrays to 1 extra arrays, right? So but time velocity will be is all time velocity is already same O of n, but we have reduced it 2 extra arrays to 1 extra arrays. If we can see that we can whether we can whether we can further optimize it or not. So for that, let's see if we can further optimize or not. So if I take a variable for that, so yeah, follow-up question is when you solve the problem in O1 extra complexity. So yeah, it means we can further optimize it, I think. Okay, so let's think. For that, what I can do. Okay, so don't take an extra prefix array. What I can do is I will use this nums value, right? What I can do is no, that will be, but if I change this nums value, then how will I multiply this suffix, right? So for that, so this is second array, right? So this was the first approach, this is the second approach. But for doing in O of 1, so for O of 1, complexity, what I can do is, I think here is written the output array does not count as an extra space of the for the space complexity analysis. So what I can do is I will simply don't take this prefix I want an extra space. I will simply take an answer array which is equals to which I will return as an answer, this answer array, and I will simply store this answer array as a prefix, use this as a prefix. So the previous which was I was doing with prefix, I can do with this answer array. I will simply store all the prefix multiplication this answer, and when I iterating this suffix from last, I will simply multiply in this, right? And now I will get my answer. I will simply return my answer. So now I can now this will be open time of space complexity with O of n time complexity, right? So yeah, let's start with coding with my first approach, which I was taking 2 arrays, nums dot size. This is the first approach, right? Where I was taking two arrays for storing multiplications. So let's take n plus 1. So prefix I plus 1 should equals to prefix I and nums of I, right? Same goes for I is equals to n minus 1 +1 is equals to suffix of I into nums of I, right? So I have stored all the prefix multiplication, suffix multiplication. Now I will simply write an answer for that, which is equals to answer of I will be what? So answer of I will be prefix of I into suffix of I plus 1, right? Because prefix of I is what? Its previous elements, it's previous, because I am storing this I0 in I plus 1, so prefix I will be its previous, and suffix of I plus 1 is its next value, right? Because I am storing this I and previous value in starting, right? So let's return this answer. Let's see whether we can pass this. What's wrong? One, 2, 624. Prefix of I plus 1 is equals to prefix of I current and to nums of I. ये तो सही है. 1 2 6 24. This is prefix is correct. I think there is some problem in suffix. Suffix of I. Okay, right. I think this is a problem. This should be I plus 1. Right. Yeah, this should be I plus 1. Let's submit it. Yeah. So, but we can't. This is not an optimal solution. So we will see the next approach again. So for second approach, what I can change is I will not take this suffix. Instead of this suffix, I can take a variable which is equals to 1, and instead of this suffix I can simply store my answer in this answer variable should be previous of I into this suffix value, and we will multiply this with nums of I, right? So this can be solved like this. This should be an upper part, otherwise it will give an comparison error. Now this we don't need, and now this should work also. From O of 2 and O of 1, let's submit it. Now we will see the third approach where we don't use this. We can use this answer array for that to store this. Right. So for that, what I can do is I will store this answer 0 in nums of 0, and this answer I should be answer of I minus 1 into answer of nums of I. Right. I'm just storing prefix array in this answer, and using this suffix I'm just multiplying this suffix to store the answer in this, right? So let's see. Okay, we have now defined vector. This should be Mm-hmm. Yeah, right. If this is n minus 1, then the answer will be simply okay. So what I can do is instead of this, I can simply just take as a 1. Right, now this looks good. Let's see. Again, this is 24 coming. Why? And it's not storing answer I minus 1 into this. This should be 1. I'm just iterating. So this answer minus 1 should equal to num psi. Okay, this should be n minus 1. Right. Yeah. Because we need to see this its previous and this next value, right? So if you don't, if you're not, let me clarify that this is num psi minus 1 because we will storing at index I its previous value, right? So in this answer I is equals to 1, we will store this 1 value. For 3 it will be 2, for 4 it will be 6, right? Like that, right? So let's submit it. This will be O1 approach because the output array is not considered an extra space here, right? So yeah, this looks good. Thank you.